word diversity. That is key to it being healthy, but it's also the amount of microbes you have, because the more of them you have, the more work can get done in the soil, basically. But one of the key balances that you want is the balance between fungi and bacteria. Um, and what happens in our modern agriculture, or in most agriculture, is that you till the land, and when you till it, the microbes that suffer the most are the fungi, because fungi are just like these long strands. I mean, the organism is made up of these long strands that kind of reach out into the soil, and they grab nutrients for plants. They transport water. They also a communication system. They transport like messengers, you could say, in the soil microbiome. So they do a lot of things that are important. But when you till, you really destroy a lot of that fungi, sometimes all of it. And when you lose those, of course, you lose all those benefits I was describing. And so one of the things in a regenerative farm, they want to um, monitor their soil for the microbial content. In industrial agriculture, when they do soil tests, they just look at what's the chemical content, like how much nitrogen, how much phosphorus, things like that. But they don't test for the biology, which is a, a big problem, because actually, when you have a healthy biology in the soil, it's those microbes that go and get the nutrients for the plant. I mean, that's the way it's been for millions of years, even billions in the case of bacteria, because those microbes have enzymes that break down the physical structure of the soil. The sand and the silt, the pebbles, even rocks that have minerals in them that the plants need, and the plants can't access those on their own. They need some kind of help. And yes, we do use products, like external products, that have minerals in them, but they're not complete, and they're also not the best way for plants to acquire nutrients. It's much more efficient for them to get them through microbes. Um, so that's critical. So that that's part of the balance. So what happens is, let's say you and I went out tomorrow and we said, "Oh, I want to, dig up this corridor of land to put in whatever, some high tension wires or whatever." And of course, we need those. But when you do that, let's say you and I, we till that down to bare ground, right? Well, that bare ground would be dominated by bacteria, because, like I was saying, we would have destroyed the fungi, right? So in a bacterial dominated soil, that gives the advantage to something we don't like, which is weeds, right? Even though weeds do serve a purpose, they kind of like are the starter. You have this thing called ecological succession. You move from bare ground all the way up to a mature forest with lots of other phases in between. And as you move along that succession, you'll have a higher and higher fungal content in the soil. And at each of those steps in the ecological succession, a different kind of plant is going to be favored. So, for instance, I've read that in our agricultural soils, there can be five times as much bacteria as fungi when it's very degraded soil, and so we get a poor growing condition for, say, grains. Like, one of the main things we'd like to eat is wheat or corn or things like that, and those kind of crops, they prosper when it's a 1-to-1 ratio between fungi and bacteria. So, in other words, 5 times, or 5 to 10 times what you would have in a weedy field, let's say, or a newly plowed field. So, so it really doesn't make a lot of sense one of the things in regenerative agriculture, one of the principles is to avoid tillage, either entirely or as much as you possibly can. There are rare circumstances where tillage can be very helpful. Usually, it's because you start with such a degraded soil that you need to, break up some of the compaction in it.